Hello, welcome to the channel. My name is Ketan. In this video, we shall be discussing some problems on ratios. This video is mainly aimed at the students of GCSE, but can be useful to anyone who is studying at that level. Now, in this video, we shall be taking a general view towards the problems on ratios and develop a general method for solving those problems. So, before we actually do that, let's recall the definition of ratio. Numbers a and b are in the ratio of p to q if there exists an integer x such that a equal to px and b equal to qx. So basically here I would like to mention that we are dealing with all positive integers. So in other words, a and b are the same multiples of p and q respectively, and in that case we shall say that a and b are in the ratio of p to q, same multiples. That's important. So let's take a few examples. So 21 and 14 are in the ratio of 3 to 2, since 21 is equal to 3 multiplied by 7 and 14 is equal to 2 multiplied by 7. So here the common multiple is 7. 114 and 76 are also in the ratio of 3 to 2, since they are both multiples of 38. So common multiple over here is 38. 1000 and 100 are in the ratio of 10 to 1, since here the common multiple is 100. The ratio m to n can also be written as a fraction m over n. So for example, we have seen that 21 to 14 is in the ratio of 3 to 2. So if we write 21 and 14 as a fraction, 21 over 14, then the common factor cancels out 7, and what we get is 3 over 2. So this 21 to 14, the ratio as we call it 3 to 2, can also be regarded as 3 over 2. But they although we use this notation, or we can use this notation interchangeably while solving problems, they have a little different interpretation, and I will explain what it means. Because understand that m to n is a ratio, whereas m over n is a value, is a rational number, and a rational number as an object is, as a mathematical object, is different from a ratio m to n. Let's see what it means. So when we say that 21 to 14 is they are in the ratio of 3 to 2, means that there is a common multiple 7, which when multiplies 3 which when multiplies 3 gives us 21, and which when multiplies 2 gives 14. That is the meaning of two numbers being in the ratio of 3 to 2. But when we say that two numbers are when we write that as a fraction 3 over 2, we mean that the first number is 3 over 2 times the second number 14, and as you can see over here, that is 3 over 2 is basically 1.5, and 21 is 1.5 times of 14. So that is a little bit of a difference between the two. All right, but while solving problems, it will not bother us much. We can use them interchangeably. There is one advantage of using the ratio notation, and it is that the ratio notation can be used for more than two numbers. For example, the ratio of 15 to 12 to 6 is equal to 5 to 4 to 2 when we cancel out the common multiplier 3. This is not possible with fractions. We cannot compare more than two numbers using a single fraction, and therefore using ratio notation is sometimes advantageous. All right, so now we come to the more important part of this video, which is useful for solving problems, and that is the actual purpose of this video. As we can find the ratio of two numbers, we can retrieve the original numbers if we know the common multiple. For examples, if we are given that two numbers are in the ratio of 5 to 3, and if we know that their common multiple is 8, then we can arrive at the original number by multiplying the numbers 5 and 3 by 8, and we can get back our original numbers 40 and 24. 5 multiplied by 8 and 3 multiplied by 8. Similarly, if we change our common multiple to 11 and keep the ratio same, then multiplying 5 and 3 by 11 respectively gives us 55 and 33. So this is how we can get back the original numbers. And the advantage of getting the original numbers is that we can deal better with numbers than with ratios. Because once we have numbers, we can add them, subtract them, we can compare them, we can equate them, we can write equations in them. So therefore, having actual numbers rather than their ratio is always better. And therefore, while solving, we should always try to convert a ratio into numbers. But very often the common multiple is not known, but that doesn't bother us, because we can always assume that the common multiple is x, and we can write, for example, here in this case 5 to 3, we can consider the common multiplier as x and write the original numbers as 5x and 3x. Although the actual value of 5x and 3x is not known, once we know that they are numbers and not the ratio, we can add them and subtract them and compare and equate them, and then that becomes much easier. So we can perform these arithmetic operations on them, which makes our job much easier. So converting this ratio into numbers is something which I would call unwinding the ratio or unfolding the ratio into numbers or quantities, actual quantities. Although involving unknown x, that is not important. We can deal with x eventually. Most often this unknown x gets eliminated, and therefore again we get back to the concrete numbers. All right, so this, keep it in mind, this is going to play very important role in solving problems. All right, so now let's take problems, and we shall consider problems in the increasing level of difficulty. So this is the first problem which has appeared in the GCSE exam AQA board November 21. So d equal to 2f, and the ratio is given as fraction over here, e minus f over d minus e equal to 1 over 4. Work out the ratio e to f. All right. So here the first most logical step is to substitute for d in terms of f, because anyway we want the ratio, final ratio, in terms of e and f, and therefore it's always good to get rid of d. So therefore we shall first write e minus f over 2f minus e equal to 1 over 4. Now again here let's unwind the given ratio into the numbers or quantities. So since e over f 2f minus e is 1 to 4, we can write e minus f equal to x and 2f minus e equal to 4 times x by the definition of ratio. Okay, now here as you can see, we have got two equations in two unknowns e and f, and both of them involve x. So most of you must be knowing how to solve simultaneous equations in two unknowns when we are having two equations in them. So here we can add the two equations. So after adding the two equations, the left hand sides, on the left hand side we shall get e minus f plus 2f minus e, and on the right hand side we shall get x plus 4x, and after cancellation we get f equal to 5 times x. That is the first step toward solving the problem. We have obtained the value of f alone in terms of x. Now getting the value of E is not very difficult, because we have the first equation as E minus f equal to x. Let's go back. E minus f equal to x. So now if we substitute here for f as 5x, we shall get E equal to 6x. So now E over f, that is the ratio that we wanted. E over f is 6x over 5x equal to 6 over 5. Look how x has eventually got eliminated, and we obtained our ratio as 6 to 5. Okay, so looking back, our main strategy was to unwind the ratio and change it into numbers, and once that was done, we solved the equations and eliminated the variable x. Okay, so that's how we obtained the ratio. Let's go to the next problem. This is a little more complicated. To the points A, B, C, D lie in order on a straight line. If AB to BD, the distance AB to distance BD is in the ratio 1 to 5, and distance AC to CD is in the ratio 7 to 11, work out the ratio of the lengths of AB to BC to CD. Let's draw the diagram first. This is a problem that has appeared in the GCSE exam at Excel board June 17. So let's draw this diagram in order. You can see the points A, B, C, D. Now by the definition of ratio, AB equal to x and BD is equal to, so this is AB equal to x and BD is equal to 5 times x. So now we can write the expression for the length AD in total, which is x plus 5x, which is 6x. All right, now the same segment AD also is divided by point C, and this ratio is 7 to 11. So we can write similar equation using this ratio. AC is 7y and CD is equal to 11y. So here it should be CD equal to 11y. All right, so here we cannot use AC, we cannot write AC equal to 7x and CD equal to 11x, because the multiples may be different. The multiples that we use to convert a ratio into numbers may be different in this case. Therefore, we have to use another variable. All right, now AD is again the sum of the lengths of AC and CD. So therefore we can write this AD as 7y plus 11y, which is 18y. Now here we have two different variables, x and y, but we want a combined ratio AB to BC to CD. So now here AB is already expressed in terms of x, CD is expressed in terms of y, BC is something that we have no expression for BC, because although we have AC in terms of y and we have AB in terms of x, we haven't obtained anything concretely in terms of BC. So if we can find some way of getting an expression for BC, then that will actually help us to find this ratio. So for that we should either convert x, or we should either express in x in terms of y or y in terms of x, and two different expressions for AD will help us to do that. Here AD is written as 6x, and here we have written AD as 18y. Both are the expressions for AD, and therefore they can be equated, and that will give us x equal to 3y. See, here again we are basically unfolding all the ratios into actual numbers, and therefore we can add them, we can compare them. That is the crux of the matter. All right, so here since we have expressed x as 3y, now we can write the lengths of AB and BD in terms of y, eliminating x. So AB was x now, which becomes 3y. BD is 5x, which becomes 15y. So now everything has been expressed in terms of y. Let's redraw the diagram. AB is 3y, AC is 7y, as we have already assumed. CD was 11y, and BD was 15y. Now it is not very difficult for us to find out BC, because BC is AC minus AB, and now both AC and AB are expressed in terms of y. So therefore BC is 7y minus 3y, which is 4y. So now AB to BC to CD is 3y to 4y to 11y, which is 3 to 4 to 11 after cancelling the common multiple y. Again here we have cancelled out the unknown. So that is what I said in the beginning, that the unknown should not bother us. It gets cancelled in the end. All right, so now let's again look back. What we were given two different ratios and we converted them into numbers or quantities, let's say, so lengths basically, as in the previous problem, by using two different multiples x and y. So here again, as I mentioned it, we are unfolding or unwinding ratios into quantities. But here the difficulty was we got our quantities into two different in terms of two different unknowns, but we could set one equation which was the length of, which was obtained using the length of AD, which helped us to express one unknown in terms of the other unknown. So eventually we ended up getting all the quantities in terms of a single unknown y, and after we did that, we easily took the ratio of all the lengths that we wanted, and we obtained the desired ratio. So what do we how can we summarize this methodology? So unwind the ratios and express them as quantities using variables, in this case x, y, or maybe they can be more, but more than just two variables, x, y, z, etc. Set up equations to express all variables in terms of only one of them, depending upon the convenience. It's convenient to express find out what is convenient, which variables are convenient to express in terms of the which other variable, and use the relationships that are given by these equations to convert all quantities into a single variable and then take the ratio. That is the general procedure for solving problems. Now we shall remember these things, and let's solve one more problem. This is also a problem coming from Edexcel board's GCSE exam. Alright, so let's read the problem and go to the solution. White shapes and black shapes are used in a game. Some of the shapes are circles and the remaining shapes are squares. So only two types of shapes. The ratio of the number of white shapes to the number of black shapes is 3 to 7. The ratio of the number of white circles to the number of white squares is 4 to 5. The ratio of the number of black circles to the number of black squares is 2 to 5. Work out what fraction of the shapes is circles. All right, here there are three ratios, and therefore when we unwind these ratios into numbers, we shall get three different variables. All right, let's begin. So by the first ratio, number of white shapes is 3 times x, number of black shapes is 7 times x. The total number of shapes is 3 times x plus 7 times x is 10x. So remember these three numbers. 3x gives us white shapes, 7x gives us black shapes, 10x is the number of all shapes. All right. Second ratio gives us number of white circles, white circles alone. 4y, the number of white squares as 5y, because this ratio is 4 to 5, white circles to white squares. Then total number of white shapes should be 9y. Now we come to black shapes. The ratio of black circles to black squares is 2 to 5. So the number of black circles is 2z. The number of black squares should be 5z. Here we are using this third and the last multiple z. And the total number of black shapes is 7z. Alright, so here we unwound the third and the last ratio and expressed all the quantities. Alright, the total number of circles is 4y plus 2z. Look at this, white circles is 4y and black circles is 2z. So therefore total number of circles is 2z. And the total number of shapes is 10x, as if you remember it. So, and the desired ratio is the ratio of circles to the ratio of to the number of all the shapes. So therefore the ratio that we are looking for is 4y plus 2z to 10x. So this is the ratio that we want to find out, but the difficulty is that this involves 3 different variables. So we must get rid of 2 variables, and therefore we need 2 equations that will express the 2 variables into the last third variable. So how do we achieve that? What is it that can help us expressing any of the 2 variables into the third variable? We shall get the two equations by comparing the total number of white shapes and the total number of black shapes. So if you remember, then the total number of white shapes was 3x when we considered the original, the first ratio, and the second ratio gave us the total number of white shapes as 9y. So therefore we get 9y equal to 3x, which means y equal to x over 3. So now we are expressing y in terms of x. So we intend to express y and z both in terms of x. So similarly for black shapes, the total number of black shapes by the first ratio was 7x, and by the third ratio that we took was 7z, and therefore 7z must be equal to 7x, which tells us that z is equal to x. So now we are almost done. We only need to substitute these values of z and y into this ratio and get our final answer. So let's write this 4y plus 2z in terms of x. Number of circles is 4y plus 2z, which is 4x over 3 plus 2x, which is 10x over 3. So the ratio of the circles to all shapes is 10x over 3 over 10x, which is 1 over 3. So which means that 1/3 of the shapes are circles and 2/3 are squares. I hope you understood this video and you enjoyed this video. Thank you for watching. See you in the next video. Bye.